This is a video on using Rolle's theorem. The question states, two runners in a 10-kilometer race finish in a tie. Prove that at some time during that race, the two runners were running at the same velocity. So we need to apply Rolle's theorem, which means we need a function. And the function that will work for this is f of x is equal to the first runner's position minus the second runner's position. Since f is a difference of two runners' positions, f is certainly differentiable. Also, if we think about the beginning of the race, when they start, they're in the same position. So if you subtract, you should get 0. And similarly, they ended in a tie. So at the end of the race, they're in the same position. So if we subtract, we get 0 again. So if A is the beginning of the race time, and B is a time at the end of the race, then we can say that f of A equals f of B equals 0. Now when we have a continuous and differentiable function, such that f of A equals f of B, we can use Rolle's theorem. And that tells us that there is a C between A and B with f prime of C is equal to 0. Now f is a difference in the position function of the two runners. So f prime will be the difference in the velocity of the two runners. So remember, the velocity is the derivative of the position. So we can say that f prime of C is the derivative of the first runner's position minus the derivative of the second runner's position, which equals 0. And that means the first runner's velocity minus the second runner's velocity equals 0. Well, if I add the second runner's velocity to both sides, then I can say that the first runner's velocity is equal to the second runner's velocity at that time C. And I'm done with the problem.